Hello everyone, welcome to VLSI Path. This is part of our static timing analysis series, guiding you from basics to advanced concepts step by step. Today we are going to discuss what is false path in STA. So let's dive in.
Now the false path. So as I discussed in the STA, we check the false path and multi-cycle path. We are not able to identify, but if when we identify it, we have to define them in the .stc file. There we define the false path from multi-cycle path, and then our tool will exclude these paths from the analysis. So false path is a path which are designed due to its functionality or it is not going to take. That's the false path. You can see a false path is a logical timing path between 2 points in a circuit that doesn't affect the functional behavior of the design and therefore excluded from timing analysis, meaning the functionality wise the path which our design will never take, that is what we call the false path. And these are not activated during the normal operation of the circuit due to specific control signal or design constraint. Okay, so here you can see a diagram here. These are the muxes and these are using the same selection line. So if selection is 0, this path will the Q2 this fast and then this slow. This path will be taken, right? And when this selection is 1, the path taken by the circuit is this S1 to this F2, meaning the slow to fast. So if you will try to optimize the path, you have to take the fast to slow or slow to fast. But let's suppose you are not aware of the functionality, you are performing the STA without knowing the functionality. You will try to optimize the slow to slow path because that's have the maximum delay. But that's not the need of this design. That's why we have to explicitly mention this false path in .stc file, so we do not optimize the path which our design is never going to take. The commands used for this false path are for the net, it will be like through net S1 to through net S2, and they are the F1 to F2. That's set false path. And set false path between two unrelated clocks. If the flop 1 is triggered by clock 1 and flop 2 is triggered by clock 2, so we will define like the false path between all the flops or the circuit which are using this clock 1 to all the circuits which are using clock 2. We do not have to take any optimization for those paths, right? So there we define in this way. And if false path between two flops, then set false path from flip flop 1 to flip flop 2.
That's all for this video. See you in the next video. Thanks a lot for watching.